Hi guys, now in this video we're going to be looking at the term HCF, or the term highest common factor. All right. Now what is the highest common factor? Now, as it states, the highest common factor of two or more numbers is the biggest number, and I'll underline that, biggest, and that's the biggest number that can divide exactly into all of the numbers without leaving a remainder. Now, what does this pretty definition means? All right, so let's just look at some practical examples, okay, to illustrate what we're talking about. So for example, let me change this. Now, if I'm speaking about two numbers, right, and I want to find the highest common factor, let's say for example, find the, and I'm going to use HCF for short. Find the HCF, which is the highest common factor of 12 and 18. Okay, good. So I'm asked to find the highest common factor of 12 and 18. First thing I'm going to do, I am going to list the factors of 12 and 18. All right, so number in the first example, I'm going to list all my factors of 12. So the factors of 12 would be, and let's list them. The first one would be 1, based on what we have understood from factors. Then the second one would be 2. Then the third would be 3. Then I would have a 4. Then I would have a 6. And remember that a number is both a factor of itself and a multiple of itself. So I would have 1, 2, 3, 4, 6, 12. These are all the factors of 12. Okay, now next thing I would have to do, I would have to list all my factors of 18. So 18, have my 18, and I'm going to list all my factors of 18. All right, so factors of 18, again, when listing factors of a number, I usually start from 1, then I'm going to check 2, and then I know a 3 can go into 18, a 6 can go into 18, and also 18 can go into itself. Okay, so the highest common factor now, as we have stated, is the biggest number. So we would have known that all of these numbers are factors, so we're really looking for the biggest number that can go into both numbers without leaving a remainder. And here we go. When I look here, a 1 is here, a 1 is here, but that's not the biggest. 2, 2, 3, 3, those aren't the biggest. Okay, I have a 4 here, I don't have any here. I have a 6 here and a 6 here. Okay, I have a 12 here, but it's not down here. 18 is here and it's not up there. So the biggest number that can go into 12 and 18 without leaving a remainder is the largest number that appears in both listings, okay, or in both sets of factors. So I would have to circle 6 and 6, because these 6 appears twice at top and bottom, and it's the biggest number. All right, and it's that easy. Now let's look at another example just to reinforce what we're talking about. Okay, I could ask you to find the highest common factor, or the HCF. Find, let's change our color. I could ask you to find, and I'm going to use HCF for short, find the HCF of, this time I'm going to use 6 comma 15 comma and 24. Okay, so first, to find the HCF, I'm going to list my factors. So I'm going to say all the factors of 6 are 6. I have a 1, I have a 2, I have a 3, and I have a 6. Okay, for 15, I can say all the factors 1, 3, 5, and 15. And my factors of 24 are, I have a 1, 2, 3, 4, 6, 8, 12, and I have a 24. Okay, now I'm looking for the largest number that appears in all three listings. Okay, so let me change my color here. So when I check carefully, I see a 1 here, a 1 appears in all three, but that's not the largest. 2 appears here, it doesn't appear here, so I have to skip that. I see a 3 here, a 3 here, and a 3 there. But when I increase, I have a 6 here and a 6 here, but I don't have 1 here. I have 5 here, so obviously 3 would be the largest number that appears in all three listings. So 3 is the highest common factor of 6, 15, and 24, and it's that easy. Okay, so in this case 3 is the HCF. Okay, and let's just, we can just connect them. All right, and in this case down here 6 is the HCF. Okay, it's that easy, guys. All right, feel free to leave a comment, or you can post any questions that you may have, and you can also subscribe to this video to get our latest releases. Okay guys, thanks and bye.